Foundations of troubleshooting Cisco voice. That's how I'd like to start off this entire series. Looking at the big picture of a voice over data network and asking the question, where can stuff go wrong? When Cisco moved into voice over IP, they really moved into a more day-to-day troubleshooting and configuration realm than they have been previously. I mean, think about it. I mean, routers and switches, you kind of set them up and they just keep working until they break, or you change VLANs. I mean, changes happen in the data network in the Cisco realm, but nowhere near as much as voice over IP. So when we move into a realm where there's a lot more configuration changes possible, there's also a lot of areas for troubleshooting. I'd also like to talk about preparation. Before you can begin troubleshooting, you have to be prepared with documentation, with a big picture of the network. So I'm going to go over the things that you should have on hand to prepare for troubleshooting and recovery. And then finally, again, big picture, I'd like to take a look at the systematic troubleshooting process that Cisco has developed, and it's a good mindset to be in anytime you walk through troubleshooting in any kind of environment. Troubleshooting a voice network isn't that much different than troubleshooting the data network or any kind of network environment that you've been in, other than the fact that we're now into a realm of understanding that there's new devices. Meaning, in order to successfully troubleshoot the voice network, you have to be familiar with the Cisco Call Manager. And I would say if there's one major focus of this entire series, it would be that guy, the Cisco Call Manager, understanding its inner workings and how it communicates to the different devices. And when things go wrong, what tools do you have on the Call Manager at your disposal to start troubleshooting and figuring out what's going on? The Call Manager, publisher and subscribers and all the database services that you have are the core, or I guess the control center that you can define, that defines your whole voice network in the Cisco realm. It's the brain behind the operations. So if these are going wrong, everything's going wrong. And couple that with the idea of clustering, to where maybe Phoenix has a cluster of call managers, and then Detroit has its own cluster. It has a call manager publisher over here. Maybe they're running the Call Manager Business Edition, which is a single server solution. So they just have one publisher over here. Now you have to worry about inter-cluster trunk relationships between these guys to allow calls to go back and forth between them. So a whole realm of understanding has to be in place with Cisco Call Manager before you can start successfully troubleshooting. You also have a whole new realm of clients that you're dealing with. Instead of just dealing with PCs and applications running on those PCs, we're dealing with IP phones. We're dealing with video cameras or webcams that are giving you video over IP streams in many cases. We're dealing with conference solutions. We're dealing with soft phones or IP communicators on laptops and desktop devices, to where a true merger between the voice and data realm has really happened on that device. And that, we're now troubleshooting the typical data connectivity, but now we have to step it up and add all the voice characteristics to that troubleshooting. So understanding the voice clients. Also, these guys right here, analog devices connected to, say, FXS ports or FXO ports that are bringing in. Those are types of voice clients, and we have to be prepared to understand not just the IP phones, but the legacy devices and how they integrate. That bleeds right into the network infrastructure. The routers, or the devices those FXS ports are connected to, have to be configured correctly in order to support and handle all of the analog to digital conversions and voice over IP codec conversions. All of those things have to be in place in the infrastructure to take place. Now, the infrastructure also runs the whole data network. So if something is whacked out on your network infrastructure, it affects data and voice as well. It's not a separate world like the PBX realm. As a matter of fact, since I started recording this video, I looked at this IP address, 10.1.2.1, and I thought, all right, well, there's a problem. All these other guys are 10.1.1. So, to conclude this, I'll say these are all /16s. So it's not a problem. Just change the subnet mask and waste a whole Class B range on our WAN links. But those are the kind of things. Network infrastructure issues, VLANs, voice VLANs, routing between the VLANs, security between your VLANs. All that has to be in your mind when you're thinking of network infrastructure. And then, of course, last and least, Unity. I hate Unity. No. Let me rephrase that. Unity is different. It's unique. It is the blind I device in the Cisco realm. And let me try to explain what I'm communicating. Unity is the voicemail solution for Cisco, and it's the black sheep of the whole certification track. Now, not the black, don't hear me wrong, I didn't say the black sheep of Cisco or the black sheep of Cisco Voice or something like that, like it's a bad product. It's a great product. But it's one of those things that not many people have knowledge on, because it's one of those devices that Cisco does not require you to know for Cisco certification. There's no certification exam for Cisco Unity. At least that's required for CCVP certification. So in that case, it just gets neglected. And to its benefit, Unity is one of those devices that you set up and it does its thing. It just kind of works. But the reason I say I hate it, and it's that black sheep, is when something goes wrong, nobody knows Unity. Nobody knows the in-depth information about Unity to begin troubleshooting. It's kind of like let's call Cisco TAC and see if they can figure out, because they've got Unity experts. So until you can get a bigger picture understanding of Unity, troubleshooting on it is very difficult. Now, each one of those areas of troubleshooting that we saw, there will be a specific section on this series. We'll have a major section. That'll be the first section on Call Manager, then the voice clients, then the network infrastructure, and then Cisco Unity to understand where to begin looking in Cisco Unity for troubleshooting information. So, when we are getting ready or preparing for our voice network troubleshooting, there are some things that we should have on hand. And this I know it's geared around voice network troubleshooting, but this goes for all network troubleshooting. These things should be in place. Number one is keep and I put in parentheses, digital network file of your network environment, meaning something that you have on the data network that is updatable, like a network diagram that has a physical and logical map of the network and so on. Now, before I even get into that, let me talk about this little digital I have in parentheses. I say digital or non-printed out because the network changes all the time, and as soon as you print something out, it's now a hard copy, and it's going to start getting data unless you regularly print out and replace all your printed network diagrams with new ones. Now, your environment may be different than the ones I've been in, but I have, and I can say this, and this sounds, I don't know, it sounds bad, but it's true. I have never, ever been in a network environment where somebody pulls out a printed network diagram that is up to date. It may be close, it may be almost up to date, but there's always things on that printed network diagram that is out of date. And what happens is people go, oh, well, you know, like that printed network diagram becomes their scratch paper. You know, as they make changes, they draw a new line with pencil or write in a new IP address. And before long, it becomes scribbled on and almost illegible, and people use that as a replacement for updating the digital copy. So do you see what I mean? So say this is your network diagram, right? You know, this link has been changed, so people just exit out on the paper and say, okay, we now have a new link over here, and then this is connected to this. That's a 10 gig per second link, you know, and you start getting IPs written in there and all that. And since they're scribbling on a physical diagram, and I do the same thing. If I've got a physical piece of paper, I'm like, oh, let me just draw it on this. There we go. And I think of that's my diagram update. So when you go back to the digital copy, which is clean, the problem is it doesn't have any of these updates that have been scribbled on, which the updates that have been scribbled on makes the whole thing illegible in the first place. Does that make sense? And the reason I say this and I spend a little time on it is because I have been in network environments where people print out on plotter paper a banner-sized network diagram, which is pristine and beautiful. I've walked into IT rooms where they have a banner, laminated piece of paper, you know, diagram that shows everything on the network, and I see that and I go, oh, that's amazing. That is an excellent diagram. Is it up to date? And the response is always, nope, that was from back in 2003. And I go, oh, well, it looks good. That's excellent, you know, and there will be some Sharpie markers scribbled on it here and there. But the point is this: when you print something out, have a printed diagram in case maybe the whole network goes down and all your servers go with it, and you can't get to the digital network diagram. You know, that's definitely an argument for it. But as soon as you print it, it becomes obsolete within moments. As soon as you start making network changes. So Enough on that. Having a digital file of your network environment, which means a physical and logical map of the network. Have physical network connections, key devices. And when I say key, I mean servers, I mean routers, switches, printers sometimes, internet connectivity. All of those key devices should be labeled and, down to the port level, port connectivity. And what I usually do when I create a network diagram is create a big picture view and then a detailed picture view. The big picture, which would be a diagram like you can see here on the screen. Matter of fact, let me just wipe that out. Diagram like you see right here. The big picture view is great for management because they look and they go, oh, okay, I see the big switch is connected to the big switch. And I shouldn't even just say management. This is also great for the server folks. People that don't deal intimately with the network environment, they just look at it and go, okay, that's my connectivity diagram. I got the big picture. But for me, I want the detail. I want, show me what port this is on the 6509 switch. Show me what ether channel bundle this is. I want the detail. So I usually will create two network diagrams, one high level, one more drilled down. And on that diagram, I'll get into the VLANs and subnets. On the high level view, I'll just say, this is the 10.1 subnet /16. In my detailed diagram, I'll say this is 10.1.1 over here. This is 10.1.2. All the subnets. On the big picture diagram, I'll have a list of all the VLANs that are in our environment. And on my detailed one, I'll show with circles where all the VLANs exist and how they affect the network environment. So, the management and server folks need to know what the VLANs are. I need to know where they are and how they are implemented. Passwords, and this I say situational. On my diagrams, don't throw a shoe at me when I say this, but on my detailed diagrams, which is for me, I put passwords to all the devices. I say, okay, passwords for my 6509. Here's Telnet. Here's my enable secret. Passwords for the routers. Passwords for the switches. So I have them all in one place. You have to. And my justification for that is you have to keep the passwords somewhere. Whether it be in an encrypted file, whether it be on your iPhone in a password application or your BlackBerry, written down on paper, they're going to be somewhere. So my thought is I protect the network diagram at all costs. I don't let the detailed network diagram get out. So that's where I put my passwords. But also remember my environment. I am a consultant for many companies. I don't really work for any one organization where I memorize all the passwords. So when I get a company that calls me for consulting work, first thing I do is I pull up their network diagram, which immediately gives me remembrance. I go, oh yeah, that's what your network is, and I immediately have all the passwords to their devices, so I can get in and start working immediately. Because most of the time when people call me, it's an emergency. So something has gone wrong, and I need that right away. So I say situational because you may not put your passwords on your network diagrams. I do. Underneath you see routing protocols, like what routing protocols are running where, what areas, and again this is on the detailed diagram. BGP autonomous system numbers, OSPF areas, where summarization is taking place. You see what I mean? Having a picture of what the network is like is so critical, and an updated picture. And I know, as I'm saying that, I know you've heard it before. I'm not the first person to say this. I know that a network diagram is good, but I can tell you time and time again where network diagrams have saved me, and I can tell you time and time again where not having an up-to-date network diagram has killed me and cost me hours when a solution could have been had in a matter of minutes. Also, having a baseline network performance and behavior chart, meaning what does the network look like normally on, processor utilization for the devices or bandwidth utilization for the devices. If you're getting calls and complaints that things are slow, which those kind of calls happen all the time. Oh, the internet's slow, or let's talk about voice. My voice, is kind of cutting in and out and choppy when I call this person. Is that normal? Does that happen all the time? If you don't have a baseline of network performance constantly going, you won't know. And I don't get any cutbacks from this, so take this with a grain of salt. The product that I use, because I'm a Windows person, PRTG. It's a paid version of MRTG. If you remember the good old MRTG, which installs on Linux, you can get it to install on Windows. It just takes this is kind of a build your own. You can make it work beautifully if you have the time. This is if you don't have time, which I don't, to build it and make it beautiful, you can pay this company money, and they will sell you kind of it's very inexpensive. PRTG will tap into each one of your devices with SNMP and give you a chart over time. You've got, your hour graph, your 5-month graph, your year graph, all the graphs over time of what all the various counters are. Here's your bandwidth utilization. Here's your performance utilization. And I would love to create a whole series just on Cisco cool tools. I could sit here and create a whole series of nuggets, at least 10 nuggets, talking about cool tool after cool tool, from SolarWinds to Kiwi Tools, which actually was bought by SolarWinds, poor Kiwi cat tools, and all the different products out there that are good for baselining your network performance and configuration. Just knowing what the network looks like is what I'm saying in that. Having a place that you can go to say, that's normal, and that's not. I have more to say on that, more on that prepare phase of having things ready, but I'm going to do that at the end of this slide because I have a thought that just kind of goes together with this. Systematic troubleshooting. How to troubleshoot a network environment or a voice-enabled network environment or a blender or a garage door that's stuck and won't open, or a lawnmower. This systematic troubleshooting process can be applied to any kind of environment where things can go wrong, is a mindset to think through. Now, I want to walk through these steps with you, and then I'm going to take them one by one on the slides beyond this. But I want to give you the big picture, and then I'm going to talk to it. So, number one, define the problem. What's going on? My microwave is not working, or the voice call is not going through. Second, gather the facts. Why is my microwave not working? It worked yesterday. That was the last time it worked. It seems to work. The light comes on. Things rotate around, but they don't get warm. What's the facts in that? Consider the possible causes. Well, it's an old microwave, so maybe the flux capacitor, or I don't know what makes microwaves work. Maybe the engine, the heating engine behind it could be wrong. So create an action plan. I'm just coming up with this microwave thing on the fly. So forgive me, since I don't have knowledge of the microwave in its entirety, my thought is call Sears. That's where I got the microwave. So I need to get a Sears technician out. Let's implement the action plan. Call the technicians. He's coming out. He says, oh, yep, you're right. Your flux capacitor is bad on your microwave. I've got to replace that. It's going to be a $500 fee. I think, okay, action plan. That's it costs more than a new microwave. Might as well buy a new all those kind of things. Implement the action plan. Make it happen. Or, change the VLAN. Let's get back to the data network. Ditch our microwave here. Change the VLAN number, modify the access list, add another interface, whatever that action plan may be, and then verify the results. See what happened. Did that solve the problem that I originally designed? Did it cause more problems? If so, have a backout. And at that point, once the results are not satisfactory, fly back to the original. Say, okay, well, let's go back here and gather the facts. What's new? Let's figure out what causes that and come up with some new action plans that can make it happen. Once you figure out the solution, document it. Document the problem and resolution, so that in the future it doesn't happen. Now, as you look at this systematic troubleshooting list, and this is kind of what I wanted to say about the last slide, but I said I'll save it until now. If you're like me, you look at a list like this and you go, okay, got it, check. But in the back of your mind, you're like, it's nothing like this. When you're in the network world, a guy runs in like a maniac with his arm cut off and says, the network is down, everything's down, you're losing money. People are screaming and computers aren't working. What's going on? You're sweating, stress it. You're like, let's make it happen. You, if you're like me, you go straight to this phase, right? Implement. You're like, okay, it's not working. Unplug cables. Let's start unplugging cables. Bad things are happening. It's down. Okay, call the ISP. You kind of do a brief version of this, which is people are screaming at me. That's the fact. Let me start doing my action plan. And when you look at this systematic troubleshooting process, you'll say, well, there's not enough time for that in an emergency. And that's why I put this little note. This does initially take longer to implement than the typical fire in the hole. I always think of Counter-Strike. Throw in the grenade, fire in the hole, everybody down. Try and fix the problem as fast as possible. But I can tell you from experience, it's better. Let me now group in that last slide. What I don't want you to hear from that last slide, when I was talking about having a network diagram and a baseline, I don't want you to hear, okay, here's my list of stuff I gotta do. I gotta have this stuff. Jeremy said, I want you to hear that, that is like a heartfelt list more than a design. That's like after years of not having those and now having a system in place where I do have those, I think, oh my word, if I can only convey how good it is to have an accurate digital network diagram in place that's not chicken scratched up on the wall with all the marks on it, to have an idea of how much bandwidth is normally used on the internet connection, and to have a process for troubleshooting is so much better than just shooting from the hip. And let me explain. Let's see if I can do this in less than 5 hours. My wife is a blessing from God to me. She has a degree in finance. She used to teach Stephen Covey's 7 Habits of Highly Effective People. That was like her mantra. That's what she used to be a manager at a bank and would teach all her employees this curriculum. She was a certified mentor and all that. And when we got married, she said, you are a mess, man. Just like every unmarried guy, right? She goes, you gotta implement 7 habits, and start thinking proactively. Don't think reactively, and start, and I'm not going to go through all the 7 habits, but my problem with the 7 habits for years is I'm like, why? I don't need to sit down and create a project plan. That's going to take hours. And she said, yes, it will, but it'll save you hours. And I'm like, I don't see it. I don't see it. I get stuff done, and I think that's a new system. They actually have a book out now called Getting Stuff Done. Like, that was my mantra. Getting stuff done. I can get stuff done. I can put out these fires. And, we for years went back and forth on this until finally I accepted. I said, you know what, honey? You're right. It's true. My whole life is putting out fires one right after another, and I never feel like I can get caught up. And she said, that's because you don't have a plan. And that's what I'm talking about when I look at the systematic troubleshooting, when I look at creating accurate network diagrams and creating baselines and all of that is about having a plan. Like, guys, we're way beyond certification right now. We're in the realm of, like, this is my heart for you as a network administrator in having a plan. I don't want you to feel like when people are running in going, it's down, get it up now, and you just feel like, stress and just sweat. I want you to feel the power, to be empowered, to turn to that person and say, I'll get to it. I'm on it. Let me take care of that. I'm not saying neglect them and act disrespectfully like your problem is not a big problem, because it is. The network's down or something like that. But you need to say, I'm not getting swept up in the mayhem of starting to try things by the time it's said and done, because, guys, I've been there. I've been where they call and they say network down. I SSH into the device and I immediately start trying stuff. 2 hours later, the network is still down, and now the configuration is so hosed because I've tried so many things that didn't work that I don't even know what we were at originally. So walking in without a plan, without a design is walking in, with blindfolded. It's sometimes it works, and hopefully it works for you every time. But if you don't have a plan, which does initially take longer, but this is a mindset to develop, then you're not going to be successful at troubleshooting. So let's walk through a sample problem using the systematic troubleshooting approach and walk through the thought process. And that's really what I want to embed in you. Is it's not so much memorize the steps as memorize or habitualize the thought process behind systematic troubleshooting. Step 1 is to define the problem. And in this case, it's fairly simple. User A cannot call user B. Now, that is the problem as reported by the user. But remember, that may not be the actual problem. I mean, the problem is most likely that the phone is not working, or that the intercluster trunk between the two is not configured correctly or down. There's all kinds of things that can happen. But big picture wise, the problem that was reported to you via a trouble ticket or a phone call is user A cannot call user B. Now we move into fact gathering mode. Gathering the facts is answering just a series of questions about the problem. For example, you're talking to user A who reported the problem, and you say, well, were you ever able to call user B? And they say, well, yeah. Until last week, I was able to call them just fine, but last week it started happening. Well, okay, are you able to call them sometimes and not sometimes, or is it just always happening? Like ever since last week, you just period can't call them. They say, well, just since last week, it just period. It's not intermittent. It just always happens. I can't call user B. And you question them and you say, well, and a lot of the fact gathering phase will be from your intelligence and your intellect trying to think through the problem, because that's why troubleshooting requires such a knowledge of how everything works. It goes so far beyond configuration and into in-depth knowledge of how things work that it's that intellect, that mindset that's going to generate the questions to gather the facts. You might be thinking, well, is the WAN link down? Is the intercluster trunk not configured between the two call manager clusters? Is user B's phone unplugged? There's a lot of questions that you have to drill to, and a lot of that may be in number one, finding what does work. Well, user A, can you call other people in the Phoenix office? Yeah, that works. I'm talking to you right now, aren't I? Sassy user. They're going to tell you what works. Yes, I can call the Phoenix office. Well, can you call people in the Detroit office other than user B? And they go, oh, well, no, not really. I guess I haven't tried because this user B is the only one I regularly talk to. So you start gathering facts to find what works, what doesn't work, and more details about the process. So tell me, what happens when you call user B? Is it a busy signal, or is it a fast busy signal? Remember, you're describing it for a user's perspective. They go, oh, it's a fast busy signal, but it happens actually after it rings. I hear it ring, like it's ringing, and then all of a sudden it goes, and it's a fast busy signal. So you're gathering the facts from the user perspective. Now, depending on the size of your organization, this may be you. You may be in fact gathering mode, or this may be maybe like a first level help desk, and you have written a script for them to read through. And anytime somebody has a phone problem, here's the questions that I need answered. Bullet point this, bullet point that. Go through this list of questions. Then you say, okay, well, we'll look at that. We'll get back to you shortly. Email that list to me, via email or a phone call, however you communicate best with level 1 help desk, and then you start troubleshooting from there. So fact gathering phase is really asking the right questions that help you to start troubleshooting in the right direction. Those facts will naturally lead into step 3, considering the possible causes. And this is where a lot of your knowledge of how the network works normally and how things communicate normally will come into play and help you generate a list of action items in the next step. So the possible causes, let's see. We've quizzed our users. They've said, yeah, it worked fine until this last week, and every time I call user B, I get a busy signal. So you think, okay, well, has Phoenix lost connection to Detroit? And while you're doing this, you can do some simple tests to eliminate some of the possible causes. For example, ping from the Phoenix router to Detroit. Again, this systematic troubleshooting takes longer, but than just shooting from the hip. But I'm not saying just create a 5-page document every single time you have a problem of, okay, here's my list of causes, and by the time you troubleshoot the problem, it's 2 days later. What I'm saying is, after you've gathered the facts, let's check the causes. Well, can I ping from Phoenix to Detroit? Do something. Get on Phoenix, ping it. Oh, yep, it's pinging okay. Can I ping from the call manager to this call manager? Is that ping? Yep, okay, it's pinging okay. Let's see. Would it be an access list? Let me check the config logs and see if there's been any changes. Well, based on my Kiwi Cat tools, that's my tool that I use for baselining configurations, there have been no configuration changes in the last 3 months on those routers. So I would say no, it's definitely not an access list problem. Let's see, did the configuration change on the call manager? For instance, call manager defines regions, which says what codec to use between the two. No, okay. Transcoding. Are we doing transcode? This is, I'm throwing out ideas right there. What is a possible cause? So you create this list, and you say, okay, from that list, I would say
this is probably the most likely cause. Transcoders. I bet you the transcoders are out of resources, so I can't convert from G711 to G729 from over the WAN and then go back when I get to the other side. And this is just an example in this case. So let's create an action plan based on that. So step 4, creating the action plan, is directly based on the previous step, which is, okay, from the most likely cause, which I figured the transcoder was out of resources, my action plan is to use the real-time monitoring tool to see, check my baseline of transcoder resources and see if my transcoder resources have been exhausted. Now, just if you haven't worked with transcoders before, transcoders will take, let's say, a G711 or uncompressed audio call and compress it as it goes over the WAN, and then once it reaches the other side, decompress it again for the other side. They're not always necessary, so it's G711 back over here. They're not always necessary, especially if you've got Cisco IP phones that can talk G729 natively, but maybe you're talking to a legacy device, like a voicemail server over here that doesn't support G729. It's something that needs a transcoder. My action plan that I'm creating is to verify the transcoder resources, add more if necessary, or maybe restart them. Maybe they've got consumed and weren't released back, so I need to reboot them to clear them out. That might be my action plan. Now you move into the fun step, implementing the action plan, which this is where you do the configuration, change the access list, verify the transcoder resources, reboot the server. Whatever action you are planning on taking, that's going to be done in this step. Now, one of the things, since we're talking in the Cisco world, one of the things that I get in the habit of doing is typing the commands in Notepad, putting them in a document, so I make a record of every change that I make. That is so beneficial for many reasons. Number one, documentation. I know what I did to fix the problem if it doesn't indeed fix the problem. Or number two, if the problems get worse, like, okay, user A couldn't call user B, but after I did what I did, and nobody can call anybody. It took down the whole voice network. I immediately know what I typed in there to reverse it back out after I do my verification phase. So as you are doing the implementation, have a record of what you are doing or what you plan on doing. If it's not as simple as syntax on a device, in Notepad or sometimes I use Microsoft Outlook tasks, where I say this is my troubleshooting task, and I'll say I'm going to reboot the Stitch server. I have one of my clients has a server named Stitch. Lilo and Stitch are the two servers. And so, I'm going to reboot the Stitch server. So I type that in, rebooted Stitch server. So I have a complete record of everything that's been done. And that is, I would say, one of the biggest things that is easily forgotten if you're in the fire in the hole mode. Let's put out the fire. You do this. Oh, nope. Oh, that didn't work. Didn't work. And an hour later, after you've tried 30 things and the problem's much worse now, or you get lost in what's actually been done, you have no idea what you've already done. So then you start running back over. Did I do that? Yeah, let me try that again. Oh, I already did that. That line's already in the access. I must have done that. And it becomes a big blur by the time it's said and done. Now, there are some problems that, and I don't want to get into the whole methodology behind it, but there are some problems that they come up. As soon as you define the problem, you're like, I've seen that before. I know exactly how to fix that. In that case, you've gathered the facts in your mind. You know the cause. You know your action plan. Just do it. I'm not saying, pull out the piece of paper and do everything for problems that you've already seen. I'm just saying this is for new trouble tickets that maybe you haven't seen before, a great way to walk through and document all of this stuff. The final two steps go hand in hand. Verify the results and then document the problem and resolution. I should probably make those green as well. But they really do go hand in hand. Once you've implemented your action plan, you're asking one question. Did the problem stop, or was the issue resolved? If not, then we take our little bunny trail right back to there. We should already have considered other causes, or if not, then let's jump back to the consider possible causes. But we should say, okay, it wasn't the transcoder, or it wasn't the access list. Let's now create an action plan for my next problem that I think it was. Or maybe when I implemented this, I uncovered something else that could be a potential cause. So let's create an action plan and implement it, and keep running through steps 3 through 6 until you verify a successful result. Once that's said and done, you can then document it. Now, I'm not saying document it so so much for you, although it is very handy for you to have, but also for other people that work with you, or perhaps those who come after you. It's one of those things that, a lot of IT people just hate documentation. I am one of them, but having a database, typically online database rather than printed out, of problem and resolution symptoms and issues and all of the common things that you run into over years can collect into a library of just gold that can be useful for you. Oh, I saw this 6 months ago. What did I do? Going back there and researching that, or as your staff grows and other people are joining you, they can now tap into the knowledge that you've created for them through a documented problem and resolution system. So there are the foundations. Again, mainly a big picture view of the mindset that you have to have going into troubleshooting anything from a Cisco voice network to a data network to a microwave oven. So we've seen the areas of troubleshooting, primary 4 areas: call manager, voice clients, network infrastructure, and Cisco Unity. That we're going to dive into each one of those areas as we go through this series. We also looked at preparing for network troubleshooting and recovery. What information do you have to have in place? Like a good logical and physical diagram. You should have the baseline of network performance and what the network normally performs like and looks like. All of those, in my mind, in a digital format that can be changed and updated when you need to. Then finally, we walk through the systematic troubleshooting process, which is more a habit than it is a step system, to get into a way of thinking as you approach these problems. I hope this has been informative for you, and I'd like to thank you for viewing.